Fourth grade lesson 2.5 is multiplying using the distributive property. The distributive property is a property you'll end up using a lot over the next several years in math, and it really is just a way to break the numbers up in a way that makes calculating with them a little bit easier. So we'll be using that property to learn to multiply using that. It will help your foundations build so that when we go into the multiplication algorithm that most of us use as adults, that it makes sense for that because that is use of distributive property. All right, so this investigation helps us see how we can break numbers up to make them easier to multiply with. Also helps them break numbers up so that you can more easily multiply in your head and maybe not have to use paper. You can use the distributive property to break apart numbers to make them easier to multiply. The distributive property states that multiplying a sum by a number is the same as multiplying each addend by the number and then adding the products. I know that sounds confusing, but you'll see the breaking apart and putting back together happen, and then this will make sense. They first asked us to outline a rectangle on the grid to model a 6 by 13 or 6 times 13. So we'll have 6 down and 13 over, and we're going to make it a rectangle. All right, so we have done that. Go ahead and make sure you have that in your book. This is a 6 by 13. And if we were to count up all of these dots in between or all of these units or squares in between, that would be what 6 times 13 is. This is 13 lined up 6 times, or 6 lined up 13 times. So this is the answer, the product to the multiplication problem of 6 times 13. But we don't really want to count them all, right? We have been working on memorizing our single-digit numbers through 10, right? We've been working on that, and so we may as well use that. We haven't been working on 13s, but we can use the distributive property to pull it back down to the level of those single-digit numbers. So they say, think of 13 as 5 plus 8. If I add 5 and 8 together, 5 plus 8 is 13, correct? So I'm going to split this into 5 plus 8. And there I have done that. 5 plus 8 is still 13. I have 5 here, 1, 2, 3, 4, 5 rows, and 8 rows here, or columns, 5 columns and 8 columns. And that's what they asked us to do. Now they say, well, let's look at it this way. We know 5 plus 8 is 13. Let's do 6 times 5. 6 times 5, as you know, is 30. So we'll put 30 in here. And 6 times 8 is how much? 48. And if we weren't sure, we could have counted up the spots. There would be 30 and there would be 48, or even better, we'll just use our multiplication grid if we don't have our multiplication facts memorized to look up 6 times 5 and 6 times 8. So we ended up with 6 times 5, and that gave us 30. And then we ended up with 6 times 8, and that gave us 48. And if I add the 30 plus the 48, that would be all of it inside, right? So I would do 30 plus 48, and that would give me 78. So what that tells me is that 13 times 6 is 78. They ask us to go ahead and model 6 times 13 again as a different sum. And this is good because I personally wouldn't have split 13 up as 5 plus 8. I would have split it up differently. Doesn't really matter how you split it as long as you totaled 13, because it was 6 times, 6 times 13. So as long as the sum of that, is the way you break it up, is still 13, you're fine. Let me show you how I would have split it up. Okay, so here is my 6 times 13 rectangle again. The area inside is what's being covered there by 6 times 13. 6 times 13. I would have split, because we just got done recently doing multiplication with tens, and that was super easy. So I would have split this into 10 plus 3. 10 plus 3 is 13, right? So here's what I would have done. I would have called 13 10 plus 3, because 10 plus 3 is still 13. I haven't changed the number. I just changed the way I split it up. This way I could do 6 times 10, which is 60. And then 6 times 3, which is 18. And then I just need to add these together to cover the whole amount inside. So let's fill this in. So we split this into 13. We made 10 plus 3 as 13. So we did 6 times 10, which was 60. I could really easily do that in my head. And then 6 times 3 to finish the 13 off right here, which was 18. Then all I have to do is add 60 and 18, and 60 plus 18 is 78. Notice I still got the same answer. It did not matter how I split it up as long as it ended up still being 13 because that was the math fact we were looking at. So for me, I try to use 10 a lot because it's much more easy to calculate with. All right, this question number 3 on page 64 asks us, what do you think is to find 7 times 23, would it be easier to break apart the factor 23 as 20 plus 3 or 15 plus 8? So would I do 20 times 7 plus 3 times 7? Or would you do 15, which would be right around here, I think, 15 plus 8? Which would be easier for you? I would think that for me, I would want to split it as 20 plus 3. 20 plus 3 is still 23. And the reason I would choose that is that because we learned that trick of multiplying with those tens, right? 7 times 2 is 14 with the 0 on the end, 140. And 7 times 3 is 21. And all I have to do now is add these two together to find out how much total there is. The total is 161. So 23 times 7 or 7 times 23, either way, is 161. Remember, multiplication is commutative, does not matter which comes first or second. So in my opinion, breaking it up as 20 plus 3 is the better route, 23 as 20 plus 3, because we learned that trick of how to do these numbers that have the 0 on the end. That would be my reasoning. So in the previous example, we used graph paper to model the problem. Eventually, you don't use any graph paper to model the problem. Eventually, you just do those things in your head. But they also wanted your brain to grasp onto it in another way, and they used our place value little models that we used before. So another way we can model the problem is use base 10 blocks to show tens and ones. So if we wanted to use base 10 blocks to model 6 times 13, remember that was 10 and 3 for 13, and that once it's 6 times over. So 10 and 3 once, 10 and 3 for 13 twice, 10 and 3 for 13 3, 4, 5, 6 times. We have 6 rows of 110 and 3 ones, 6 rows of 13. Once we have it like that, we can just count 10, there they have, break the models into tens and ones, 10, 20, 30, 40, 50, 60. 6 times 10 is 60. And then we have 3, 6, 9, 12, 15, 18. 6 times 3 is 18. We add the tens and the ones to find the product, 60 plus 18, 60 plus 18, 60 plus 18, 60 plus 18, and that is going to give us 78. So if your brain needed it to see it another way, there's another way for you. And really that's all this lesson is about, is just pulling apart those numbers to make them easy to multiply using the distributive property. So go ahead and give that a try on Think Central. If you are not sure about this, please do let me know, and we will spend some time in class going over this a little more in depth if you need extra practice.